So homework 3 starts off with scientific notation with a positive exponent. Scientific notation is usually used in science for really big numbers or really small numbers. If I'm going to have a positive exponent, I'm going to have a value that's greater than 1, because a positive exponent is going to tell me to move my decimal to the right, since our number system is base 10 and we're multiplying by powers of 10. So if I take negative 3.86 times 10 to the 4th power, I'm going to have my negative 368, and then I'm going to have to add 2 more zeros to that. Anything that's bigger than 1,000, they usually like you to put the comma in just because it looks pretty, not that you really have to have it there. So negative 36,800. Now if you are doing scientific notation things, in case you know you do take a science class and you're going to use your calculator, it's best if you're doing it on your calculator to put it in parentheses. If you were just putting the scientific notation and changing it into standard form, you wouldn't need the parentheses, but if you're doing calculations like multiplying or dividing or whatever with scientific notation, you need to tell the calculator that that all goes together. So I would have negative 3.86 times 10 to the 4th power. I can see my board is not quite writing exactly where I want it to, but that'd be the best way to put it into your calculator if you were doing a calculation with it, so that it knows that all has to go together. If I'm going to write 27 million in scientific notation, then when I have a number in scientific notation, my first part of my scientific notation is always a value between 1 and 10, or negative 1 and negative 10. So basically you're just sticking the decimal right behind that first digit. I'm going to have 2.7, that's going to drive me crazy. I'm going to have to fix that in a minute. And then I'm going to count the spaces that I need to move my decimal. I can drop off all the extra zeros, which is kind of the point of scientific notation, to shorten it up. I have to move my decimal 1, 2, 3, 4, 5, 6, 7 places. So 2.7 times 10 to the 7th. So if you were going to write negative 12,000 in scientific notation, what would you have? Negative 1.2, putting my decimal behind that first digit, and then times 10 to the 4th, because I have to move it 4 places to get it to the end. I got to fix the bull, should fix my problem. The next ones are doing with the negative exponents. If you have a negative exponent, you actually are dividing by your power of 10, so it moves your decimal to the left. So if I'm doing negative 3.56 times 10 to the negative 4, I have to move my decimal back 4 places, which is going to add 3 zeros in front of my 3. I have to remember that's negative, and because it looks pretty, you'll see that the zero's in front of the decimal point. So negative 0.000356. If I take my decimal, move it back 1, 2, 3, 4 places. Number 5, you're putting it in scientific notation. Again, basically you're trying to eliminate all the extra zeros. You're going to put your decimal behind that first non-zero digit. So you'd use 2.56 times 10 to the, and then if I had to move it back to the original spot, I end up having to go backwards. How many places? 4. So I'm going to have 10 to the negative 4th power. 2.56 times 10 to the negative 4. So number 6. If you're going to put that one in scientific notation, what would we have? Times 10 to the negative 3. The next ones, we are multiplying numbers written in scientific notation. When I'm multiplying them, I'm multiplying the like parts together, so I'm going to multiply the numbers in front together, and then I'm going to multiply the base 10 numbers together, and when we multiply with the same base, we add our exponents. So I'm going to take the 3 times the 1.3, which would be 3.9, and then 10 to the 8th times 10 to the 6th, I'm adding my exponents. So I'm going to get 3.9 times 10 to the 14th power. Occasionally when you're multiplying in scientific notation, this value in front ends up being a number that's not between 1 and 10 anymore, and you do have to change your answer into scientific notation, so you'd have to move your decimal and adjust your exponent as needed. So number 8, if I'm going to do that one, 4.8 times 0.8 would give me 3.84 times 10 to the first power. Now normally you wouldn't put 10 to the first power, you just put times 10. On the Alex program, sometimes it's a little goofy and it wants the exponent there, so stick it in there. Normally I would just put 3.84 times 10, but since they're doing scientific notation, I guess they want that there. Number 9, if you multiply that one out, 2.3 times 5.5. Yeah, if you want to use your calculator to do that, that is fine and dandy with me, because that's what I would do. Unless I didn't have a calculator in my hand. 12.86 you said?
12.65.
12.65. Man, I can't even hear. Times 10 to the negative 5. So this is one that I would have to convert into scientific notation, because 12.65 is not in scientific notation since I don't have a value between 1 and 10. If you're not sure of how to adjust your exponent, change it into standard form first and then put your answer back into scientific notation. If this is times 10 to the negative 5, I'm going to move my decimal back 5 places. So I'm going to have 0.0001265. Now if I move my decimal where it should be, I'm going to have 1.265 times 10 to the negative 4th, right? And so now my answer is in scientific notation. And when we are dividing numbers in scientific notation, the same kind of thing. We're going to divide the numbers in front, subtract our exponents, since when we divide with the same base, we subtract the exponents. So we would have to take negative 6 divided by 4, which would be
Negative 1.5.
negative 1.5 times 10 to the, and our exponent would be
4.
not 4, but negative 4, because I'm going to do the top one minus the bottom one, so 6 minus 10 would be negative 4. Just for fun, on your calculator, we're going to do negative 6 times 10 to the 6th power, and then we're going to divide that by 4 times 10 to the 10th power, and of course acres. Depending on what kind of calculator you're using, it'll show up a little bit different on your screen. Casio's put the little 10 way over on the side, but just so you know how it looks and works and whatever, in case you happen to be taking a science class where you have to do scientific notation. She's using a fancy phone and it doesn't have scientific. Oh, it doesn't have parentheses. Oh.
It has like sine and cosine and all that.
And it should show up as negative 1.5 times 10 to the negative 4th somehow on your calculator if you're using a regular calculator. Oh, number 11, if I go ahead and do that one. Negative 4.8 divided by negative 4 would be 1.2 times 10 to the second power. 11 minus 9 would give me positive 2. Number 12, same kind of thing. I'm going to take the 5.76 divided by negative 2.
Negative 2.88.
Negative 2.88. times 10 to the
-7. No, I mean,
-3rd.
negative third. Because I'm actually going to end up adding that. And so times 10 to the negative third. All right. Again, the next are just some terminology things. The degree and leading coefficient of a univariate polynomial. Polynomial just means there's many terms. Univariate, we have all the same variable in there. The degree of your polynomial ends up being the highest exponent if it's a univariate one, not a multivariate one. And the leading coefficient is the coefficient that is in front if I put it in best order. In algebra, the best order is to put your polynomial in descending order. So if I rewrote this in proper order, I would have the negative 8x to the fourth plus the 20x cubed minus the 5x, since there's no x squareds, plus 1, and that's what they call descending order. So the degree of this polynomial, I'll do it backwards anyway. The degree is 4. It's a fourth degree polynomial since that's my highest exponent. My leading coefficient is the negative 8 because that's the coefficient of my leading term. So, did I really need to rewrite that to figure that out? No, but I did it for fun anyway. Because it was fun, right? Yes, you guys are so excited today. If I'm picking out my leading term on number 14, which would be my leading term? Negative 10v to the 8th. So the degree of this polynomial is going to be 8, and my leading coefficient? Negative 10. And number 15, I'm going to try to sneak in there so I don't have to pause the video and erase the board. If I'm looking at negative 15x minus x to the fourth minus 18 minus 10x cubed, which one is my leading term? Negative x to the fourth. So the leading coefficient of that is negative 1, exactly, because that's negative 1x to the fourth, and the degree is 4. So they thought they were being tricky by leaving the 1 off of there, but you guys are all smart, so you knew that. Simplifying our sum or difference of two univariate polynomials. I'm just basically combining my like terms. The parentheses are there to separate the two polynomials from each other. If I'm adding, I'm just going to add my like terms. If I'm subtracting, I might want to use my distributive property first, or some of you can subtract without doing that. But I'm just going to combine my like terms. So negative 7t squared plus 2t squared would be negative 5t squared, 3t plus 4t, positive 7t. Make sure you get the plus sign in there when you type it in. Negative 1 plus 5, positive 4. So negative 5t squared plus 7t plus 4. Number 17, again, we're just adding, so we're combining our like terms. Negative 4y squared plus 7y squared would be 3y squared. 6y plus y.
7y.
Positive 7y. And if I have negative 5 plus 5,
0.
it's 0, so it basically cancels it out. I don't need to put a 0 term in there. So 3y squared plus 7y would just be my answer. Number 18. Since this one has subtracting, technically subtracting is adding the opposite, or you could say, oh, I'm going to multiply by that negative 1 in front of my parentheses. So I would want to change all those signs. Negative 2t squared minus 5t and minus 1, since they were all positive. And then I can go ahead and combine my like terms. So 4t squared minus 2t squared is 2t squared. 3t minus 5t, negative 2t, and negative 7 minus 1, negative 8. Okay, you already know that one. multiplying a univariate polynomial by a monomial with a positive coefficient. So I'm basically just using my distributive property and multiplying that out, multiplying the coefficients, adding my exponents on my variables since I would be multiplying with the same base. If I take 10y squared times 9, I would get
90y squared.
90y squared. And if I take 10y squared times negative 7y to the 4th, I would get
Negative 70y to the 6th.
negative 70y to the 6th, exactly. Those are not like terms since my variables aren't the same, so I can't add them together. That's just my weird looking answer. By the way, on the Alex program, when you're typing that in, when you get to an exponent, if you just hit the space bar, it brings your cursor back down. I see some people clicking all the time. It's fine if you want to click, but it's faster if you just hit the space bar and it drops that cursor down for you. Number 20, 5x to the 7th times 6x to the 2nd would be 30x to the 9th, and then 5x to the 7th times positive 4x,
20x to the 8th.
positive 20x to the 8th. So 30x to the 9th plus 20x to the 8th would be your answer. Number 21, 5w times negative 6. Negative 30w. 5w times a positive 3x to the 3rd. Positive 15x cubed w, or wx cubed, doesn't really matter the order of that since we have the commutative property. I think she typed that one wrong. 5w times negative 4w to the 7th. Negative 20w to the 8th. I'm going to guess that my work study person probably typed that wrong, and that was probably supposed to be a w, or yeah, w instead of an x, but oh well. You know how to do it anyway. The next three are multiplying binomials in two variables. Binomials just mean you have two terms in the parentheses. Probably back in high school they call this foiling all the time. You multiply the first two together, the outside pair, the inside pair, and the last, and then combine your like terms, just to give you an order to multiply. So first pair, 5a times 5a would be 25a squared. My outside pair, 5a times positive 8b, positive 40ab. My inside pair, negative b times 5a, negative 5ab. And then my last pair, negative b times positive 8b, negative 8b squared. Now in these ones I do suggest that you try to put them in alphabetical order just so you recognize they're like terms. AB and BA are the same thing. Then I can combine my like terms, so I'm going to have 25a squared. 40 minus 5 would be positive 35ab minus 8b squared. And I get a trinomial for my answer. So 23, if we multiply that out, 4y times 8y, 32y squared. 4y times negative 3z, negative 12yz. Negative 3z times 8y, negative 24yz. And negative 3z times negative 3z, positive 9z squared. So combining my like terms in the middle there, 32y squared minus 36yz plus 9z squared, then would be my answer. Let me do this one and then I'll come help you.
Sure.
24, if we do that one quick, x times 5x would be 5x squared. X times negative 8w, negative 8wx. Inside, 3w times 5x, positive 15wx. And 3w times negative 8w, negative 24w squared, so your answer would be, everybody all at once, 5x squared plus 7wx minus 24w squared. Multiplying conjugate binomials. A conjugate is when you have the same two terms just with the opposite sign in the middle. We'll use conjugates when we want to simplify something with a radical on the bottom that has two terms down there, stuff like that. But when you multiply conjugates, a special thing happens. The middle terms cancel out. So if you multiplied it out the long way, 7u times 7u, 49u squared, 7u times negative 5, negative 35u. 5 times 7u is positive 35u, and 5 times negative 5 is negative 25. You can see then, oh, yep, the middle terms cancel out. I end up with what they call the difference of perfect squares, 49u squared minus 25. So if you recognize right away while I'm multiplying conjugates, you know the middle terms are going to cancel out. So basically you can just do the first and the last. The reason you like to recognize the difference of squares is because when you do factoring, if you recognize that's a difference of squares, you should know you're going to end up with conjugates, and it makes your factoring a whole lot easier. And so I just FOIL them out the normal way because, you know, I spend a whole lot of time learning 10 different things. Okay, we're just going to multiply this out. 2 times 2 is 4. 2 times 3x, positive 6x. Negative 3x times 2, negative 6x. Negative 3x times a positive 3x. Negative times a positive is a negative, and 3x times 3x is 9x to the second power. My middle terms will cancel out, and so I'm going to have 4 minus 9x squared. Go ahead and do number 27. A squared minus 36 is then your answer. 28, 29, and 30, squaring a binomial. If something is squared, it means it's multiplied by itself. Because there's adding or subtracting in the middle, you can't distribute that squared like you would with multiplication and just do u squared and 5 squared. It doesn't work that way. If I did it the long way, this means u plus 5 times u plus 5. If I FOIL it out, u times u is u squared. I get a positive 5u, and I get a second positive 5u, and then I get plus 25. So I get u squared plus 10u plus 25. So they're going to give you a little shortcut if you want to remember the shortcut. If you don't, just write it down twice and FOIL. But the shortcut says to square the first, take 2 times the first times the last. So 2 times u times 5 gives you that 10u, and then square the last, because you know your middle term is going to happen twice. So 2 times the first times the last gives you what your middle term would be. Otherwise, just write it down 2 times and FOIL it out. Works the same way. So 29, go ahead and either multiply that out, or if you want to use a shortcut, square the first, 2 times the first times the last, and square the last. So, you are getting
16b squared plus 32b plus 16.
What sign did you have in front of your 32b?
Yeah, it should be the
Yeah.
16b squared minus 32b plus 16. So 4v squared would be 16v squared. 2 times the first would be 8v times negative 4 would give you negative 32v. And then if you square a negative 4, you get positive 16. Go ahead and do number 30 there. So we're getting what on that one?
4y squared plus 24y plus 36.
4y squared plus 24y plus 36, exactly. Multiplication involving binomials and trinomials in two variables. Basically, it's the same kind of thing we're doing. We end up taking the 3v times both terms in this set of parentheses, the 3y times both of them, and the negative 4 times both of them. And so 3v times 4v would give me
12b squared.
12v squared. 3v times a negative y,
3b, or negative 3by.
negative 3vy. Then we're going to do our middle term, so 3y times 4v,
12b.
positive 12vy. 3y times a negative y,
Negative 3y squared.
negative 4 times 4y, or 4v, can't read because I scribbled over the top of it.
Negative 16b.
Negative 16v, and negative 4 times negative y,
4y.
positive 4y. Looking for any like terms, here we have a pair of like terms. Now in the ALEKS program, they're going to rearrange it and put it in descending order. You don't really have to worry about doing that unless you really want to. So I would probably just leave it in the order it is. 12v squared, negative 3 plus 12 would give me positive 9vy minus 3y squared minus 16v plus 4y. All of that gets to go in for your answer since you don't have any other like terms to come up. Dennis, did you have a question?
No.
No? Okay, just checking. Now, the suggestion I make for some of our older students that have kids is because, you know, your kids always have to come in and bug you right when you're in the middle of something, is if you tend to get lost where you're at and what you're doing because you get interrupted while you're working, one little trick you can do is basically just to make a box, and I'm making my box 2 by 3 since I'm multiplying 2 by 3 polynomial. 2u plus 7, 5u minus 3y minus 2, and it just kind of keeps you organized so that if you would get interrupted in the middle of the problem, you know where you left off. 2u times 5u, 10u squared. 2u times negative 3y, negative 6uy. 2u times negative 2, negative 4u. And then multiplying by my 7, 7 times 5u, 35u. 7 times negative 3y, negative 21y. 7 times negative 2, minus 14. So my answer would be what?
10u squared minus 60y plus 31u minus 21y plus
Smoosh that in there. And there's my answer. So just one way of keeping yourself organized, especially as they get longer, if you have to do a 3 by 3 one or something like that. Not that you have to do it, but if you want to, go ahead. So number 33, if we're going to multiply that one out. 3w times 7w.
21w squared.
21w squared. 3w times 2u,
6u.
positive 6uw. 3w times negative 1,
-3w.
negative 3w. My second term, 2u times 7w,
14uw.
positive 14uw. 2u times 2u,
4u squared.
positive 4u squared. 2u times negative 1,
-3u.
negative 2u. And then my negative 7 times each of those, so negative 7 times w,
-49w.
negative 7 times 2u,
-14u.
and negative 7 times negative 1. Positive 7. Combining my like terms then, my answer would be
W squared
21w squared
plus 20uw
plus 20uw, combining those two,
-52w
minus 52w, combining those two,
plus 4u squared
plus 4u squared, since that one didn't have a buddy,
-16u
minus 16u
plus 7.
plus 7. And all of that would get to go in for your answer. Alrighty.